All right, in this video, we're going to be reviewing 9-6, talking about dilations. This is the last lesson of chapter 9. So this is going to finish up our transformation chapter. So a dilation, if you recall back when we did it with triangles, is when you enlarge or reduce a shape proportionally, right? So a dilation is a similarity transformation that enlarges or reduces a figure proportionally. The figure looks exactly the same, just either bigger or smaller. So here we have an example. So what we're going to do is they'll give us a point, some point to base it off of, right? And they'll say, this says, draw the dilation image of triangle ABC, which is here, with center O, which is here, and a scale factor, that's R, of 2. Scale factor is R, ratio or scale factor of 2. Okay, so what that means is, we're going to use something. You can use a ruler. I'm not going to use a ruler. Just something to kind of measure. Okay, we'll go a little closer. And whatever the distance from your center to one of your points is, I'll do it with red. Whatever this distance is, it looks like it's just over 2 squares, right about to here on this little note card I'm using. And the scale factor is 2. So we're going to go the same direction. We're going to go out 2 of those, right? So I'm going to go out another one on that same plane. So I'm going to go out to about right there. I want to make sure it's a straight line. Right from here to here. Boom. So now that I've moved B, now it's been dilated with a scale factor of 2. Now it's going to be B prime. So the distance from O to this original B, right? Let's say it's 1. So whatever the distance from O to the new B, to B prime is, that should be double what the original distance should be, right? Same thing through point C. Whatever this measurement is, here, I'll use the other side here. Through point C, from the center point O through point C, whatever that is, it looks like it's about 3 squares here. I got to go out that far in the same direction again to get C prime. Okay, and then same thing with O to A. I'm going to go in that direction, go through point A. It looks like it's about 2 squares here. So I'm going to go about 2 squares here. And this is my new A, my A prime. So now to draw this triangle, I'm just going to connect those 3 new vertices. So if you had a scale factor of 3, whatever this first measurement is, you just do 2 more of those so that the distance from here to your new B, if there was a scale factor of 3, would equal 3 of the original measurement. I hope that's making sense. My old hands in the video. Ugh. All right, so then this is our new, you can kind of see here, they've already drawn it for us, but this is our new image. So I didn't have anything to help me. All I did was take the center, guide it past this point on my original triangle, went past it to create a new triangle. How do I know when to stop? Like, why didn't I keep going up here, right? Because the scale factor is 2. So whatever this is, I needed 2 of those. Whatever this original distance is, I need to double it. Same thing here. Whatever this original distance was, I had to double it. Whatever this distance was, I had to double it. And I still go right past that original vertex to make my new vertex. Right past this original point to make the new point. Okay, so it's pretty easy when you have a guide like that. So we have 6 problems here to try together. Here's the first one. We have a scale factor of 2, and the center is S. So we're going to draw past point S, from point S past A, and it looks like with my note card here, the distance from S to A is about 2 squares, and my scale factor is 2, so I need 2 of those. So I'm going to go past that there, and this is going to be A prime. And same thing over here, from S to B, looks like it's about 2 squares, maybe not quite. So I need to go about that distance. Let's see, 1, 2, about right here. This is going to be B prime. Whatever this distance is, if the scale factor is 2, then I need to double it, right? To get this entire distance. And then I'm just going to connect my new vertices to draw my new figure. So it was line AB, now it's line A prime, B prime, right? Okay, scale factor here of 1/2. Oh, one thing I wanted to say, because we don't cover it on the back. When your scale factor, let's write it up here at the top. When your scale factor R, scale factor R, if it's less than 1, if it's between 0 and 1, or 1, it's greater than 0, it can't be negative, it's greater than 0, but it's smaller than 1, so in other words, it's a fraction, right? Then your shape that you're dilating is a reduction. Reduction. If R is bigger than 1, if R is greater than 1, then it's an enlargement. Enlargement. Okay, so if R is less than 1, but greater than 0, it's a reduction. If R is bigger than 1, it's an enlargement. What if R is exactly 1? If R equals 1, then it's congruent. Nothing changes. It stays exactly the same. It's like multiplying a number by 1. The number doesn't change. Okay, so less than 1, it's going to get smaller. Bigger than 1, it's going to get bigger. Equal to 1, it's not going to change at all. All right, so that being said, we have this guy right here. We're going to, this is going to be a reduction because this is less than 1. 1/2 is less than 1. R is less than 1, so this is a reduction. So when I measure this with my little thing I'm going to use here, it looks like it's about, from this point to S, 1, 2, 3, 4.5 squares, right? So I want to go half that. So that's going to be 2 1/4. Half of 4.5 is 2 1/4. So I'm going to go about 2 and a little more than 2. So my dot's going to be right here. That's going to be R prime. The measure from S to C, let me use the other side here. I want to line those up, and it's got to be half that. So right now it looks like it's about, how many squares? 1, 2, 3, 4, 5, 6 squares. So half of that would be 3 squares. So it would be that in line there, yeah, that in line there. It's going to be 3 squares, and it's going to be right about here, it looks like. That's C prime. And then R is going to be half, whatever this measurement is. It looks like it's about 3.5. So we're going to go 1 3/4. 1 3/4 would be half. So 1 right about here. It's got to be in line, but right about here. That doesn't look right, does it? Boom, halfway. Boom, halfway. Boom, halfway. Yeah, it should be. Boom, boom, boom. Yeah, it's a reduction. It's not exact. If you use a ruler, it'll be exact. It should be proportional. The triangle should look the same. This one's just a little bit smaller. Should be a reduction, okay? Next one, R equals 1, okay? Here's our center point. Well, if we were going to measure the distance from here to here, and then we've got a scale factor, if we just multiply it by that scale factor, it stays the same, right? If this length was 2, and we multiply it by our scale factor, it's still 2. So all I'm going to end up basically doing is drawing a new shape right on top of my original shape. So W prime, X prime, Y prime, Z prime is going to look exactly like the original whenever your scale factor is 1. Nothing changes. Okay, next one here, when the scale factor is 3, we're going to line up our center point, which is, does it give us an O? Use a ruler or the image of dilated center S. Scale, yeah, center S. All right, so this is our center S. It looks like from here to T, it's about 1.5. So from here to our new guy, 1.5 times 3 is 4.5, right? So we're gonna go 1, 2, 3, 4.5, right about here. And it even gives us this line right here. So this is going to be boom. Okay, this is S. Distance from S to T is 1.5. To 4.5. Okay, so this is T. distance from S to C is about, same thing, 1.5. So we're going to go about 4.5 in line. And 4.5 is going to get us right about here. Oh, perfect. That's C prime. This was T prime. And then S, the measurement from S to this line is about 1 block. So we're going to go about 1, 2, 3. It's like 3/4 of a block. It's not a full block. So we're going to go 3/4 times 3 is 9/4, or, wait, 3/4 times 3 is 9/4. That's 2 1/4. 2 1/4 would get us right about. No, that's not what I want. I want this distance. So if that's 3/4 from here to the line, then from here to this line. Okay, so I'm keeping this S the same. All right, so my new triangle is going to be this guy here. So I kept the same S point. I didn't move it at all. So with this S point, I either have this little triangle, STC, or the big guy, S prime, T prime, C prime. And it has a scale factor of 3, so this big red guy is 3 times bigger than this little guy, but they all share the same vertex S. All right, R, 2/3. Okay, so we have point S right here. The distance from, this is going to get smaller now. This is less than 1, so this is a reduction. Just to remind you, so we're going to be drawing a smaller shape. Okay, so we're going to measure. And it looks like from S to M, it's about 1 3/4. So 1 3/4, that's 7/4, right? And we're going to multiply that by 2/3. So we're going to get 14/12, which is 7/6. So almost, it's just over 1. Just over 1. Okay, sorry, my husband called in. For this one, we said it should be just over 1 box, so right about here, just going right past this little box mark here, right? So that should kind of give us a guide. So here's this S prime, or sorry, that's M prime, not S prime, M prime. P, the distance from S to P is about, looks like 3 full boxes. So 3 times 2/3 equals 6/3, which is 2. So I should draw something in line with P from S to P, but only 2 boxes away. So about right there. That's going to be P prime. Draw a straight, oh, that wasn't a good straight line. Okay, and then from R, from S to R, it looks like it's about 1, 2, 3.5 boxes. So 3.5, 3 times 3 is 7 halves times 2/3. Whatever your original measurement is, you multiply it by the scale factor. So 7 halves times 2/3 gives me 14/6, which is 7/3, or 2 1/3. So it's going to be about 2 1/3 boxes out in line between S and R. 2 1/3, it looks like about right there, about-ish. About right here, that's R prime. So I'm going to draw a line from there to there. And now I got to get V prime and W prime. From S to V, it looks like it's about 3 boxes, so 2/3 would be, oops, right in line there, would be 2 boxes right here. So that would be V prime, draw a line straight down, and, oops, sorry. And last but not least, I need to come up with W prime. The distance from S to W is about 1 3/4, which changes to 7/6, right? Which is just over 1 box. So I'm going to go just over 1 box in line with that W, just like right there. And there's my W prime. So I draw that and I draw that. So this new shape here should look just like the old shape, but just shrunk down and smaller, right? And we measured it proportionally. Okay, last but not least, this guy has a scale factor of 1. That's the easiest kind because it doesn't change. So if the distance from S to F, whatever that is, we're going to multiply it by our scale factor, and it's going to stay the exact same distance. So that's going to be F prime. Same thing here, G prime. Same thing here, H prime, J prime, K prime, and then back to F, F prime. So this is the same. Whatever our two problems that we had, what was it? 3 and 6. 3 and 6. When the scale factor is 1, the shapes are just congruent. If it's less than 1, if the scale factor is less than 1, you have a reduction, or you're going to shrink your shape. If it's larger than 1, you have an enlargement. Okay? Let me know if you have questions.